Hello and welcome to our project presentation, comparing the water quality of the Colo River to the Cockle Creek. I'm Ben Crunkhorn and my co-presenter is Jack. The importance of water quality cannot be expressed enough. Water quality can be influenced by a number of factors, pollution running into the waterways from agriculture, sewage, urban runoff, and mining. These are considered as point and non-point sources. Wastewater runoff from mining can introduce toxic substances such as heavy metals and chemicals into waterways. These toxic substances will leach into the waterways and into the sediment, affecting all life that interacts with the water. The aim of this project is to conduct an aquatic macroinvertebrate water quality survey for the purposes of comparing the data from both locations that are being focused in this project, the Colo River and Cockle Creek. We will collect the data and assess it and then compare the water quality that we have established from our macroinvertebrate samples. The reason we are doing this is that both Jack and I have a shared interest in the field and have a shared enjoyment in conducting biological surveys. Both of us have conducted similar surveys in the past under supervision, and this is the first time both of us have had a chance to conduct this sort of survey on our own self-driven project. As I said before, the importance of water quality is paramount, especially here in Australia. Water is just limited. The growing population, that's becoming more pressing, and it's important to maintain water quality for drinking purposes, health and well-being of the population, and to allow the population to enjoy recreation on the water. It also offers a vital experience of future employment, paths that both Jack and I want to take. The specific objectives of this project are to catch and identify aquatic macroinvertebrates, then use the data that we have taken from these samples to assess the water quality, analyze and tabulate the data, and finally compare the data from both the Colo River and Cockle Creek locations to give us an understanding of the health in both locations as a direct result of the pollution that affects the waterways. Mining runoff being the main contributor to the pollution at Colo River, and urbanisation and sewage being the main contributor to the pollution at Cockle Creek.
For the methodology, not much has changed since our last progress seminar. The only additional activity that we conducted was that we resampled our sites 2 weeks after our initial sampling. 3 sites were sampled at both the Colo River and Cockle Creek. These sites were labelled Upper Colo, Central Colo, and Colo East for the Colo River, and Upper Cockle Creek, Centre Cockle Creek, and Lower Cockle Creek for Cockle Creek. At each of these sampling sites, we conducted the 2 samples so to provide repetition and reliability to our results. The equipment used included a 215 micron kick net, 6 sampling containers, a sample tray, gloves, and the Water Watch sampling guide and the water bug app. So the methods remain the same from our previous presentation. Firstly, the net is placed against the substrate or the creek floor. Generally, this technique works best in flowing water, but can still work in still water. What you do next is kick the substrate vigorously upstream or away from the net. This in turn allows all the invertebrates that have been kicked up to be pushed into the net with the flow of the water. Once the samples have been collected, it just helps to dip the net carefully back into the water to remove the excess substrate. The sample is usually transferred into a picking tray where you can then start identifying the sample. For my sampling, it was easier to transfer my sample into a large sample containers and take them off-site to be identified. It's also good just to check the net to make sure there are no invertebrate samples stuck in the net. Using gloves, you can begin separating the invertebrates from the sample for identification. I found it easier to remove the invertebrates and place them in a small container or lid. Once the invertebrates have been separated, you can begin identifying them. For this, we use the Water Watch sampling guide as well as the water bug app. Identified invertebrates were recorded into a table and shared between Ben and myself for further research. These steps were repeated for the samples at each location. This slide here shows how we identified our invertebrate samples and then how we determined the pollution tolerance level. This image on the left depicts the first page of the WaterWatch Invertebrate Sampling Guide. And these images on the right are some of the invertebrate samples that we encountered in our sampling. We then determined which species they were based on the images provided in the sampling guide, as well as the WaterBug app. And as you can see, they have a pollution tolerance number, which we recorded. So invertebrates with a score of 1 to 2 are very tolerant to pollution. 3 to 5 are just tolerant to pollution. 6 to 8 means that they are sensitive to pollution, and 9 and 10 are very sensitive to pollution in the water system. If a water system is polluted or contaminated, then there is less of a chance of observing invertebrates with a score of 9 or 10 in the water. For the overall results, it was observed that the pollution tolerance was present among all the sites at both the Colla River and Cockle Creek. As mentioned earlier, we used the WaterWatch sampling guide to identify our samples, and we then determined the pollution tolerance. What we found was that both our sites showed similar results. As you can see here, the Central Colla River site and the Center and Lower Cockle Creek sites demonstrated a similar range of pollution tolerances from very tolerant to very sensitive. The Upper Colla River site resulted in the lowest range of pollution tolerances, but did contain invertebrate samples which are sensitive and very sensitive to pollution. The sites Colla East and Upper Cockle Creek showed smaller ranges of invertebrate tolerance levels, but also contain more tolerant species than invertebrate species sensitive to pollution. So what does this mean? The sites with a large range of tolerance and sensitive scores, such as Central Colla River site and the Center and Lower Cockle Creek site, generally have better water quality due to the fact that sensitive and tolerant species can inhabit both these areas. Whereas sites like Upper Cockle Creek and Colla East demonstrated a lower abundance of invertebrate species with more tolerant and very tolerant species than the other sites. This indicates contaminants are present in the water. Here you can see the invertebrate samples that I identified for Cockle Creek. This was my first set of sampling and located a range of different invertebrates. For each of the sites, I took 2 samples and put both results together to gain an understanding of the pollution tolerances. What we found in this first sampling was a larger number of tolerant and very tolerant species in the water system, with only one type of sensitive species found in each site, as you can just see there. In comparison though, in the second set of sampling, a greater number of sensitive species were uncovered. As you can see here, this range of invertebrate species means that the water quality is of better quality than first interpreted.
Here's the first set of my sampling data. This is the raw data tabulated. I've ordered it in the listings of invertebrates, their family order, and pollution tolerance. And here is the second set of data from the second day of sampling that I did 2 weeks after the first set.
Due to the wide ranges of invertebrate species and their relative pollution tolerance, it can be concluded that the water quality present at both the Colla River and Cockle Creek is of a high standard. Across all the sampling sites, invertebrate species with a sensitive pollution tolerance score were identified, meaning that the quality of water is of adequate quality for them to survive. Although it should be noted that a larger number of tolerant invertebrate species were identified, which leads to the conclusion that the water is of higher quality but still possesses some contaminants. Overall, further testing should be conducted to determine the true quality of water at each of these locations and to develop strategies to minimize the amount of contaminants entering these water systems.
Personal learning outcomes that both Jack and I have gained from this project specifically, the group work experience, it's been a lot of communication between Jack and I, a lot of working back and forth, and it's allowed us to expand on our experiences with group work, and I'll expand on that more in terms of the communication restrictions of COVID restrictions that were applied on us and everyone, limiting our methods of communication and exchanging of information. Our macroinvertebrate sampling like I said before, both Jack and I have used kick nets or something similar in the past, but this time we've going out on our own, doing it ourselves. It personally definitely expanded my capability and skill set in sampling macroinvertebrates, as well as identification and handling of the samples, methods in which to examine the samples and identify the macroinvertebrates that we caught. Applying the scientific method to the project, something that's well practiced but can always get better at. Research design and coordination with a research partner. So research design is something that's become very important at this part of my study and Jack's as well. And then coordinating that design structure and putting it all together with someone else as a challenge in itself, but as a very big learning curve. And I think both Jack and I did a great job at that. And time management, something that's always being worked on as an adult, but it's something that has a lot of facets to it. And with this particular project, there was a lot of time management that needed to be done to make sure that we got assignments in on time and got our results processed and shared between us. Working within the COVID restrictions, I won't expand on that too much because we're all very well aware of that, but it was definitely a challenge to work with those, which then leads me to the constant use of Zoom meetings and virtual communication resources very heavily in this project throughout this semester, constantly expanding on how to use those programs and other ones like them. Thank you very much for listening to our seminar.